Poon sometime around last year. Essentially, it has one kind of inherent flaw, or I would say security risk. So how plasma architecture works is all transactions are accepted by default, unless someone argues, unless someone provides proof that that transaction is not correct. So this can introduce risk into the system. It means by default I accept all transactions, even false ones, right? I can accept false information into my blockchain if nobody argues with me in time. And so I think this is kind of a big design flaw and should be mitigated against. So we avoid that in this case, but we get all of the benefits. So this kind of architecture ends up being flexible and modular. I mentioned earlier, we can make any design choices between these two chains. If one chain is running proof of work, the other one can run proof of stake. If one of these chains is public, the other one can be private. Any kind of design choice to kind of fit whatever business requirement that you want. It ends up being scalable. Let's say we have a product chain on the left here, and it fills up with transactions. It can't keep up with the transaction load. Well, so in this case, we can kind of horizontally, linearly scale out. Think of something like cloud computing or Amazon. We can spin up new instances of chains, essentially doubling our capacity for transaction load, or tripling, or kind of indefinitely as long as we have resources to spin up these new chains. It ends up being interoperable. The whole ecosystem is completely interoperable within itself. Interoperability means that two blockchains can securely, cryptographically securely communicate with each other and pass transfer value and smart contract state. But beyond just within the ecosystem, we're actually using the tools that others are using to communicate between large public chains. So with this kind of architecture, we could hook up to Cosmos, we could hook up to Polkadot, right? These are internets of blockchains. Or if those don't seem efficient or we can't use them properly, we can fall back to plasma architecture. The benefit here is that at any point, we can checkpoint on any other chain. So this gives us the ability for disaster recovery. If I'm on a small chain that's not supported by a lot of validators, and someone attacks that chain, but I've checkpointed on a large public chain that's very secure, then I have a place where I know this was a valid state that I can roll back to. And last is security. So in addition to the checkpointing security feature, this kind of architecture allows us to mitigate or maybe sandbox or compartmentalize applications. So if you think about something like the Ethereum network, if I deploy a contract on the Ethereum network, I deploy it in one place, but it's network-wide. So if something's wrong with that contract, it affects the whole network. But that's not the case in this kind of architecture. We can box off certain parts of applications, and they don't have to affect other applications or things running in the ecosystem. And so I'd be happy to talk to you guys more in detail. Any questions are welcome. I'm here with my compatriots Amin and Eugene, and we have a booth out here. Feel free to come ask me questions. I love to talk about blockchain all the time, so thanks.